morning students, and welcome back to another video. Today we are discussing the doubts or the explanation of the second law of motion. One of you had the questions and commented that please explain the second law once again. So here it is. First of all, the statement. The second law of motion states that the rate of change of momentum is directly proportional to the applied unbalanced force. So rate of change of momentum. Rate of change of momentum is proportional to applied unbalanced force. Is proportional to applied unbalanced force. Now what does this statement mean? So we go back to the first chapter, that is motion. If you remember, acceleration. What is the definition of acceleration? Rate of change of velocity. Rate means the amount of time. Okay, don't get confused. So acceleration stated that A is equal to V minus U upon T. Rate of change, that means change in velocity in certain amount of time. Rate of change of velocity. Over here we have rate of change of momentum. So what is momentum? Momentum P is mass into velocity. But if it is P initial, then it is m into u, and if it is P final, then it is m into v, where u is initial velocity, v is final velocity. Simple. But forget about this now. We will only talk about momentum. The change of momentum in certain amount of time is called rate of change of momentum. So change in momentum, that is final momentum minus initial momentum, in certain amount of time is called rate of change of momentum. Now the next part is directly proportional to the applied, so not equal to sign, directly proportional to the applied unbalanced force. So this is the relation, second law of motion. Here in this particular relation you have the statement. The rate of change of momentum is directly proportional to the applied unbalanced force. Now we move forward. We know that the final momentum and initial momentum are given by m into v minus m into u, where v is final velocity, u is initial velocity upon time t, as it is. Okay? Now, next part, taking mass as common because we are talking about the same object. So the next step is F proportional to m into v minus u upon t. Now they all are in multiplication and division, okay? And v minus u upon t is, we know, acceleration. So I can write F proportional to mass into acceleration. This is your final relation. You can define that mass into acceleration of the object gives me the force applied, or gives me the relation to the force applied. But this is not your mathematical calculation. Whenever you are converting a relation into mathematical formula, you always have a constant balancing the equation. Okay? Whenever you are converting the relation or the expression into mathematical formula, then you always have a constant that is balancing the equation. Okay? And by many different scientific researches, it has been found that the value of k is 1. So what you get is F is equal to 1 into ma, and finally F is equal to m into a. So this is your final answer and final formula to find the force, that is mass into acceleration. Now I know this value of k. If it is already 1, why substitute the value of k? See, you cannot directly convert the expression into a formula. Okay, you will first need to give the constant and then give the value of constant. Over here, the value of constant is 1, but there are different mathematical, you can say, relations in physics. You will study one in the gravitation chapter as well, and they also have different constants for balancing the formula. And the value of this constant is not always 1. We have different constants for different relations. You will study about more in the future, and they don't have the same value 1. We have different constants for different purposes and different formulas, and the value of that constant is not always 1. This is for this case only, remember that. So I hope that this answers your question. The formula and the derivation, I will go through it once again. The statement of the second law of motion is the rate of change of momentum is directly proportional to the applied unbalanced force. So this is the relation. Rate of change of momentum, change in momentum upon time taken, is directly proportional to the applied unbalanced force. Writing the values of momentum, final momentum and initial momentum with final velocity and initial velocity. Taking mass common, so it becomes force proportional to mass into v minus c upon t. That we already know as acceleration, we studied in the motion chapter, and force proportional to mass into acceleration. And removing the proportionality sign, we have a constant balancing the equation. F is equal to k into ma, and the value of k is found to be 1, and therefore F is equal to 1 into ma. Finally, we have the formula for force, that is F is equal to ma. Similarly, if you have any other doubts in any of the videos, please do mention them in the comment section and I'll be happy to make such videos. Okay? Till then, have a nice day.